So what, gotta get my, what's this thing over here that I'm gonna call? What am I drawing out over here, Gabriel? What is this space over here?
Can you hear me?
Yes, I can.
Okay, the space is a local memory
It's the local memory?
that we're gonna open right now.
No, this space that I've drawn out here on the right-hand side, what is this?
Sorry, the global memory.
Aha, that is our global memory, exactly. All right, while I've got you on the mic,
yeah,
I've got my global memory over here, right? I'm gonna put my call stack over here. What's on the bottom of my call stack always, Gabriel?
It's going to be the copy array multiplied by 2 function.
No. What's always where am I running copy array?
Oh, sorry, global memory, yeah.
The global, exactly.
Yeah.
So the global execution context is always right down on the very bottom of my call stack, right? Because that's where I'm running everything, right? Cool. So walk me through what's going to happen in this first line of code here, Gabriel.
Yeah, so we declare a function copy array multiplied by 2, and it takes array as a parameter, and we are putting it in global memory and assigning it to the function definition of copy array multiplied by 2.
Very well said, right? We're declaring a function, copy array, and multiply it by 2. We're storing its whole function definition. And again, that is literally everything from here to here. We're taking all of that code, storing it over here in our global memory. So what's happening on the next line of code, Gabriel?
Then we are declaring a const myArray and assigning it to the array with the elements 1, 2, and 3 in global memory.
Excellent. So we're declaring a variable myArray, assigning it equal to out of array, the values 1, 2, and 3 in it. Keep going, Gabriel. What's next?
I would ask you to please scroll your the screen a little bit because I can't see. Perfect. So we're declaring another variable called result and assigning it to copy array multiplied by 2 function call, which will be uninitialized and will be undefined for the moment. Okay.
So in order to get that value, what do I have to do, Gabriel? A couple of things.
We are going to have to open a local memory.
You were saying it right the first time, and then you changed yourself. A local what?
A local execution context.
We got a local execution context, which inside of it has
there's a local memory. Yeah, correct.
Local memory, exactly.
Yes.
And so in order to do this, right, we're going to actually, and I'm just going to make it nice and easy. We're saying this is what we're running right here, right? So this is copy array and multiply by 2 with myArray as the argument. So when I create this local execution context, how do I know that this is the local execution context that I'm working inside of, Gabriel?
We immediately push into the call stack.
Exactly. Oh, I gotta go back to my pen. Copy array multiply by 2. Let's call it that. Okay. So let's jump over to Paul in New Jersey. Take me inside of this function. We've created this local execution context. We've set up our local memory. What am I going to do here?
Then you're going to set the array to the value of my array with the elements 1, 2, 3.
Exactly. So my array has a value over here, right, of 1, 2, 3. So I'm going to match up my argument and my parameters. I'm going to declare this variable array and set its value equal to 1, 2, 3. Exactly. What am I doing next?
then you're going to declare constant variable output with an empty array and assign it to an empty array.
Output equals empty array. Okay, so I got output. It's this empty array. I got to figure out how to do it. So now we're going to go into this for loop. So in order to kind of like draw this out nice and easy and kind of like walk us through everything that's going to happen inside of here, I'm going to kind of put array up here at the top. And we've declared this constant output, which if we skip ahead a line or two here, we can see we're going to return output at the end, right? But we're obviously going to do some stuff to what's in array before we can push it out, return it out to our global memory. So when we do that here, we'll end up in the end with output down here, right? So if anybody, this is like totally your first time, never seen a for loop before, kind of walk through basically what's going to happen here as I jump into here. We're going to start with a value of 0, right? Oh, let's go with yellow. Going to start with a value of 0 kind of for our I. It's going to help us keep track of where we are inside of our loop. Next, we have this as long as I is less than the length of array, right? So we have array up here has 3 arguments in it, or three values inside of it, right? So 3 indexes. We have 0, 1, and 2. Arrays are 0 indexed. The very first thing inside of an array is always at the 0 index, and then it just goes up numerically from there, right? So we got 0, 1, 2. Great. We're going to increase I every time we go through this loop, and we're going to do this. We're going to do every iteration of this loop. We're going to do everything inside of these curly braces right here. So as I do this, oh, I'm erasing the wrong things. 0, 1, 2, sorry. So I'm going to go into this loop. Eric, why don't you take us from here and tell me right off the bat, we're going to start with 0. Right? We said let I equal 0. So as we move inside of our loop, what are we going to do as we go in? Walk me through.
Okay, so inside the loop, the first thing that we are going to do is we are going to push array at I, and right now I is 0, so that would be 1 times 2. So output now at its index 0 is 2.
So we push that in, right? So just to kind of walk through that, the push method is going to push a new value to the end of this array. So right now it's an empty array. So the end of the array is the beginning of the array, all right? So we're going to take 1. We got there because, as we said, everything is indexed, right? So array at the index of 0 is 1. Multiply that by 2, we get 2. We're going to push that in. Keep going, Eric. What happens next?
Next, we are going to increment I. So I is going to go from 0 to 1.
Okay.
And then we are going to check to make sure in our for loop that I is still less than the array length. And it is, because 1 is less than 3. So then we're going to go back into the loop again and push array at the index of I, which is now 1. So that would be 2 multiplied by 2, which is 4.
Okay, keep going.
Then we're going to increment I again. So I is going to equal 2. And we check again to make sure that I is still less than array length, 2 is less than 3, so we're good. And we go back into the loop again, and array at I, at index 2 is 3, so 3 times 2 is 6. We push that onto our new array, and we increment I one more time, so I is now 3, and 3 is not less than 3, So our loop is now ended, and we return output out of the function.
And where do we return that to, Eric?
We return it back into global memory, into the variable result.
Exactly. And once I return out of this function, what happens?
Then the function copy array multiplied by 2 is then erased from the call stack, or popped off the call stack rather, and then we're back in the global execution context.
Absolutely, right? We came into this when we popped it onto the call stack. We ran our code. Once we returned, we exited out of this local execution context. We popped it off the call stack. And that is exactly the right kind of like verbiage there. We popped it off the call stack. So we push things onto the call stack. We pop things off the call stack as we do this. So now we've gotten back to our global thread of execution, our global execution context, and there's no more code. We're done. That was it. Nice and easy, right? We copied an array, multiplied in it, everything inside of it by 2, spit it back out. Cool. Great. What if we wanted to copy an array and divide everything inside of it by 2? Looks very similar. Looks very similar to what we just did. But let's walk through it. Let's walk through how we're going to go about doing this. Can everybody see that? Not cutting anything off on anybody? Okay. Andrew, get me started here, man.
All right, so first we're going to declare a function called copy array and divide by 2. We're going to store that function definition in our global memory. And then the next thing that's going to happen is we're going to declare a constant labeled myArray and assign that the value of an array containing the elements 1, 2, and 3.
Okay, keep going.
Now we're going to declare a constant labeled results, and we're going to, it's going to be the evaluated result of calling copy array and divide by 2 with the argument myArray, but as of now it is undefined since we haven't run it yet.
Absolutely. Okay, so if I want to run that, what do I need to do, Andrew?
We're going to need a local execution context, which we're going to call copy array and divide by 2. And then we're going to push the call to copy array and divide by 2 onto the call stack, and our thread of execution moves into our local execution context.
All right. We got our global. We have copy array and divide by 2 that we have run. Inside here, what's over here on the right-hand side of this local execution context, Andrew?
We've got a local memory.
Got our local memory. We're going to just paste this up here so it's nice and easy to see, so we know exactly what we're doing. We got our local memory here. Keep going. You're on a roll, man. Walk me through what's happening here.
All right, so the first thing that we always do is pair our arguments and parameters. So we're going to assign myArray to the value of 1, 2, and 3, an array containing the elements 1, 2, and 3, excuse me.
Are we calling it myArray still?
Well, in our function definition, it is called array, which, yeah, so I guess in this local execution context, it's called array.
It is. But its value is, as you said, myArray, which we're going to get from, where are we getting that value from?
We're getting that from the result label. Well, I mean, it's declared, myArray is declared in global memory, and then we know that that's the argument that we're passing into this call to copy and divide by 2.
That's what I was looking for. We're going to get myArray from global memory because that's where we stored that value. Exactly. So we've got array, we've matched up our arguments and our parameters. We're inside of our execution. What's the first thing we're doing inside the execution there?
We're going to declare a constant labeled output and assign that the value of an empty array. And then we will open our for loop.
All right, so again, we've got up here 1, 2, 3 is our array to start with. Down here, we've got output. Currently is an empty array. Keep going, Andrew. You've got this.
So we have a variable I that is initialized at 0. And we're going to check to see if that is going to be less than our array length, which in this case is 3. And because it is, we're going to take our array at index I, which is 1, and divide that by 2, and push that result into our output array. So I believe that is 1/2, or 0.5.
Keep going.
So now we're going to increment our I variable. So I is 1. We check to see if it meets our conditional. 1 is less than 3. So then we continue with our array at index I, which in this case is 2 divided by 2 is 1. So we push the value 1 into the end of our output array.
Okay.
Now we increment I again. I is 2. 2 is less than 3. So then the array at index 2, which is 3, we divide that by 2 and push that value to the end of our output array. Now we increment I again. I is 3. 3 is not less than 3, so that ends our for loop. So then we move down to the next line of code, and we will return output back to global memory and assign it to result.
We're right over there, and exactly correct. Very well said. All the way through. You assign that back out to result. A couple more things are going to happen. What's going to happen now?
So now we are done with this local execution context, so we will pop it off the call stack. We will garbage collect that local execution context, and our thread of execution will move back into the global execution context.
And we are done with our code. So this looks a lot like that, right? Looks almost exactly the same. Exactly the same, right? Cool, nice and easy. We can just do the same thing over and over and over again, right? Let's do it again. We're gonna add 3. I'm kidding, we're not gonna do this again. This is, what principle are we breaking right here, Luke?
Dry.
Exactly, dry principle. We don't wanna repeat ourselves. Don't repeat yourself. This is what we're kind of getting to over and over again. There's lots of ways we keep doing the same thing over and over again, right? But well, if I want to copy an array and I want to be able to do anything I want to each of those elements, Warren, what can I do, man?
Well, you can pass in functionality as an argument in a function.
We can generalize our function. And yes, we can pass in functionality, right? So each time, the first time we were multiplying by 2. Second time we were dividing by 2. The third time we were going to add by 3. But we kind of got bored and we were like, I'm done with this. I'm not repeating myself anymore. Let's move on, right? So now, as you can see, this function looks very much like the other functions, but there's something new here. We've got another parameter in our function definition. We're calling it instructions. Why would I call this instructions, Warren?
Well, this is what you're telling the function to do.
Exactly. What did I say at the very beginning of this class? What is a function?
It's a thing that you pass in instructions to, and it gives you a new output.
Exactly. It's just a list of instructions that we're giving to the computer, right? So You can call this whatever you want. You don't have to call this instructions when you define it as a parameter in your function, but we're going to call it instructions right now because it just makes the most sense, right? So we're going to copy an array and manipulate now, right? So instead of having to write a brand new function for all the different things that we could possibly want to do to that array, wouldn't it be nice if we could just also practice that dry principle, pass in a set of instructions to our function that will run on each element in that array that we want to manipulate. Here we go, copy, array, and manipulate. So let's walk through it. Let's see what this is all about. Elisa, it's your time to shine. Are you ready?
I'm ready.
All right, let's do it.
All
Walk
right.
me through. What's the first thing that's going to happen?
Do you want me to set up our environment or just jump into the code?
Let's set up the environment. What am I missing?
All right, we're missing our global execution context, we're missing our call stack, and our thread of execution.
As we said, the whole board is going to be our global execution context right there. Everybody can see all the pieces of the puzzle here? Okay, awesome. So, and our call stack. Correct. This is our global execution, as you said, and our thread of execution is just going to take us down through our code as we go through here. So, our environment is set up, Elisa. What are we going to do?
All right, so on our first line, we have a function definition with the label copy array and manipulate.
Okay, and so what am I going to do with that function definition?
We're going to put it in our global memory, and we're going to store the entire definition there.
Exactly. Okay, what's next?
Let's see, then we're going to move down to another function definition with the label multiply by 2. We'll store that in our global memory with the entire definition.
Change the color of this one. We'll talk about why in a minute. Okay, so we've got another function definition stored in memory.
And
What's
then
next?
from there, we're going to move down to the last line where we have a constant variable with the label result. So we'll go ahead and store that in our global memory. And it's going to be assigned the evaluated result of invoking copy array and manipulate. And it's passing in 2 arguments, an array of 3 numeric values, and a callback, which is our instructions multiply by 2. So we know that we're going to be setting up another local execution context.
Exactly.
And we're going to push this onto our call stack. And
Okay.
our thread of execution will move into this functional execution context, and we're going to pair our parameters with our arguments.
Okay, so let's do that.
So our array is going to be assigned the value of an array with the elements 1, 2, and 3, and we'll store it in our local memory.
Okay.
And then our instructions will be assigned the value of our function multiplied by 2.
Exactly. So here, I'm not actually like bringing the label multiply by 2 over, right? All I'm bringing over is what it is, right? And I'm bringing over this whole functionality. And this is why I drew it in blue over there, because now over here, we're going to do that. Can you guys hear that screaming outside? Sounds like my girlfriend's parents have a dog. And if any of you have met me before, maybe you've seen my pit bull, Bailey, before. She's very playful. Much more playful than any other dog ever really wants her to be. So she's constantly, no matter how many times you pull her off, she'll just be like, oh, okay, I'll leave her alone. And then you like turn your head and then she's over there just literally biting her on the ass, being like, come on, play. And then the dog, the Springer Spaniel, gets very upset about it and starts going crazy and starts biting back. And my dog, she's not aggressive. She's a pit bull, but she's like totally lovable. She's not a fighter. She's a lover, not a fighter. But so she gets scared, and then it's just this whole barking match, and I can hear them all like screaming at each other, stop, pulling them apart. I don't know. This is what I deal with like 7 times a day, every day now that I'm here. It's kind of entertaining, but I'm glad that they're the ones dealing with and not me. I'd rather be in here with you guys. But yes, I completely digress here.
It's
We've
okay.
taken this whole functionality. We've taken this whole functionality and we've passed it in. Now we're storing it as instructions inside of our local execution context here. So keep going, Elisa.
All right, so now that we've invoked copy, array, and manipulate, we're going to move into the body of that function. And we have, let's see, another variable, a constant variable with the label output. We're going to put it in our local memory, and it's an empty array.
Okay, so let's set this up just like we've set up our other kind of examples, just so we can kind of see like what we're starting at and where we're going to in the end, right? So we're going to write up here at the top, we're just going to say array 1, 2, 3. Looks very familiar. Down here at the bottom, output, as we said, big empty array. Okay. What's next, Elisa?
All right, so now we're going to move into the for loop.
Okay.
And I has been initialized at 0. And it will run the length of the array, and it will increment by 1 each time. And so then we move into the body of our for loop. And we are going to, let's see, we're going to take our output array, and we are going to push the invocation of our instructions with the argument array at the index of I.
Okay. So here's where things change. So if we're still using that output push, right? We're still pushing something into our output array. But as you said, now we have the invocation of our instructions. So whenever I invoke instructions, what's going to happen?
So we're going to create another local execution context.
Exactly. Inside of here, I have another local execution context, which has its own local memory. And what else happens here?
We are going to push it onto our call stack.
Okay.
And our thread of execution will move down into this execution context.
Okay.
All right.
Keep going. You're on a roll.
Okay. So we're going to pair our parameters with our arguments here.
Okay.
And our parameter for multiply by 2, which is our function for instructions, is input. And we're going to assign the value of input array at index I, which would be our 0th index, which is 1.
Okay.
And now we're going to return our input times 2, which will be 2.
Where do I return that to?
We are returning this to the local memory of copy, array, and manipulate to the output.
Exactly. So we're going to now push 1 times 2 into our output array. Exactly. Okay. Let's get Toby. Let's get you some practice, man. Walk me through the next couple of iterations of this loop here. So
absolutely.
I returned out of instructions, right? Mm-hmm. So what has to happen now?
So you return out of instructions. Let me find it because I don't really know where you're at. Okay. So you return out of instructions, and then we're going back. Are we incrementing now in the for loop? Okay.
Well, we're incrementing, but first, once I leave an execution context,
Okay.
what happens?
So it gets popped off of the call stack, and it gets sent to garbage collection, and erased out of there. Super.
Okay. I was gonna leave it there just because I'm lazy, but
And then, okay, so we go back and we increment I by 1.
okay.
So I is now 1. 1 is 1 less than the array length, which is 3. Yes, it is. So we go into the loop block.
Okay.
Output dot push, and so we open up the instructions. We're calling the functionality because we have the parentheses, and setting it to the element with the element as an argument, and so we open new local execution context.
Okay. Look how fast I just drew that execution context.
What
What happens when I open up an execution context, Toby?
Then, so what happens is it gets its own local memory, and then we check if we have any parameters. Not well, yeah, we have the element array I. So
we missed one step.
Yeah.
Whenever we open up, how do I ever, if in order to get into this thread of execution, what do I have to do? Into this execution context.
So the thread
how do I ever know what execution context I'm in at any given point in time?
Oh, excuse me. Yeah. So it gets pushed into the call stack.
Exactly. Exactly.
Yeah, absolutely.
Okay. Now you got it. Keep going.
Yeah. Okay. So now instructions are multiply by 2. So the input has got an input, and the input is our element, our with the index 1, which is the number 2.
Okay.
Okay. And now we return input times 2. So we go into the local execution context and do the calculation.
Okay.
And we assign that, we return that. Yeah, we return the evaluated result of that calculation out into the parent function. And do we send it to output? Yeah, and then we log it in the array. Oh, it gets pushed into output. Okay.
Exactly. It gets pushed into output. As we return out of this function execution, this execution context, we're returning it to where we called it, right? We said output dot push instructions array at index I. So array at index I was 2, as we said.
Okay.
Pass that in as our input. We ran the functionality. We're returning it. Now we have to actually push it to where we said. So we return out. We pushing that in there. What happens to this execution context?
Now it gets popped off the call stack, and erase sent to garbage collection, and then we increment by 1 again.
Okay. So what does I become now?
I becomes 2.
I becomes 2. Okay.
Then we check our conditional again. Is 2 less than 3? It is. So we go back into the for loop block, and we execute instructions again.
Okay. So whenever invoke instructions, what happens?
So we open a new local execution context, and we push it on the call stack.
Exactly. We push it onto the call stack. Okay. Keep talking.
Push it onto the call stack, and then we check for our parameter, which is input, and assign it the number 3.
Okay.
Integer 3.
And where are we getting 3 from?
Getting 3 from array. So we're getting 3 from 3. So we're getting 3 from array. 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 3 from array from array, right? Yeah.
Yeah, of course. You're right.
Sorry.
You're right.
So we're getting so we're getting I'm super tired. So we're getting 3 from index 2 in the array, and then so we go into multiply. We go into the local execution context and do the calculation. Input times 2, which is 3 times 2, which equals 6. I think.
What do we do with that?
Then
Number 6.
We return that to push, which pushes it into output, sorry.
Okay. And then what's next?
And then we pop it off. Instruction gets popped off the call stack, erased and sent to garbage collection. Now we're back in that local execution context. And we return output back to global.
Well, we're still inside of our loop, aren't we?
Oh, excuse me. Yes, we go into I. Is I increment to 3? Excuse me. Is 3 less than 3? It is not.
No.
So we jump from the for loop out of the block, and we hit return output. So we return the output.
Where do I return output to?
To the global execution context or the global memory.
Right over here to result, where we started. And now I've returned out of the copy and manipulate execution context, Toby. What's next?
So now we pop copy array and manipulate off the call stack. We send that to garbage collection, and we're back to global.
And we're done. All right, let's get a round of applause for our participants here. We just did the same exact thing, right? But this time, as Warren said, we passed that functionality into the function. We passed the functionality into the function. Instead of having to write a new function to copy array, multiply by 2, copy array and divide by 2, copy array and add 3, we just created a copy array and manipulate. We passed in the functionality that we wanted to run on each iteration. Andrew, you have a question?
I do, yeah. There's been some interesting questions in the chat regarding the push method. Would that get its own local execution context, or does it not merit that?
Yes, no. Technically, the push method would get its own execution context. It's a very good question, because the push method, a method is in and of itself just a function, right? So it is running a function, but for the purposes of this example, I didn't draw out those kind of execution contexts. But yes, 100%, the push method has its own execution context.
Do all methods then have an execution context because they're all just functions?
They're all just function. A method is just another word for a function, right? But a method, we typically call it a method because it's a function attached to a class. You'll learn more about that if you come to the OOP, classes and object-oriented programming, JavaScript, the hard parts, which is usually taught here by Phil. And he will teach you all about data, functionality, putting them together. Austin knows what I'm talking about. Derek, what's up, man? You got a question?
And just all on a similar note, the for loop would also theoretically have its own execution context?
The for loop has, this is a good question, and I haven't found like a good answer. It has its own kind of like block scope, right? So like when we talk about inside of that for loop, it's not actually accessible. Like if I come back down here, and before I return out, I say console.log I'm going to get an error because it doesn't know what I is, because I actually only exists inside of that for loop, which is its own kind of like block, like lexical scope. I don't know if it opens up a whole execution context, but it is definitely scoped inside of its own kind of like for loop. Mm-hmm. So yes.
Where is the where are the I values being stored then? In the local memory for
the for loop. So most likely I would imagine that in an essence it has its own kind of execution context as well, but I've never really seen it kind of like explain that where it's drawn out. But the I definitely lives inside of its own kind of variable environment, inside of that lexical scope, inside of that for loop.
Okay, thanks.
You got it. Any other questions or thoughts on kind of like what we've just done here, right? Let's kind of move up here. How was it possible that we did this? How did we pass this functionality into another function, right? If you come from like a background of like Java or some of these other languages, you're like, you can't do that, man. You can't pass a function into a function. It doesn't work. Well, in JavaScript, it does. Functions in JavaScript are just first-class objects. They're just another object, you know, just like passing any kind of other object into a function. We're storing it in memory. It's just an object that we're kind of like using. It can coexist with and be treated like any other JavaScript object, assigned to variables and properties of other objects, passed as arguments into functions. Can also be returned as values out of functions. A function that returns another function. Wei-Fei, what is a function that returns another function called?
Higher order function?
Not exactly. Well, I'm not going to get too much into it. This is a whole other JavaScript, the hard parts, where you can come and learn for 2.5 hours on closure, where we kind of like attach functionality by kind of having a function return another function. But yes, here we are. We can have functions passed in as arguments. We can have functions returned out of other functions. So in this case, you said you came here to learn about callbacks and higher order functions, Kyle, and you haven't said callback or higher order function a single time since we got here, other than explaining the name of this thing. But we just learned about callbacks and higher order functions. So in this example over here, let's see, who haven't I called on? Morgan. In this example, oh, he's like, oh shit, he got me. In this function over here on the left, what is the higher order function?
The higher order function. Would it be the copy, array, and manipulate?
Exactly. It's copy, array, and manipulate is our higher order function. And Morgan, for edit, what is our callback function?
Would it be the multiply by 2?
Yes. In this case, when we pass it in, the function we pass into another function is our callback function. But the outer function that takes in a function is a higher order function. So a higher order function, all a higher order function is a function that takes in another function in its definition. It has a function as one of its parameters. So the outer function that takes in the function is our higher order function. The function that gets passed in is our callback function. And that's all there is to it. Remember at the beginning of this when I said, when we get to the end, you're gonna be like, oh, it's not as complex as it sounded like. A higher order function is just a function that takes in another function as an argument. Callback is just a function that gets passed into another function. That's it. That's all it means. Sounds complex. Higher order functions take in functions or pass out functions, as I said. Who was it that said that? Is that Derek? I was calling on somebody. Now somebody turned their camera off and it shifts everybody's pictures. So I'm like lost, like who said that? It was Andrew? Was that you? Doesn't matter. A higher order function, yes, takes in a function or passes out a function. But just in terms to describe these functions, any function that does it, we call but there's nothing different about them inherently. So when we talk about those like map, reduce, filter, right? We always kind of use that arrow function, right? That we kind of pass in. That function that we pass into map or filter or reduce is our callback function. But map, filter, and reduce in and of themselves are higher order functions because they take that function and do it. So this copy, array, and manipulate realistically is basically doing what map does, right? It's taking a callback function, taking an array, and doing something, doing the same exact thing to every element of the array as it goes through. That's all it is. This is what a higher order function is. Thumbs? Questions? Comments? Concerns? All right. So, callbacks and higher order functions. They simplify our code. They keep it dry. What does dry mean? What's that? Oh, somebody said something. Question? Hello?
I think somebody was just unmuted. That's all.
Oh, okay. Thank you. Sounded like a question. No worries, but dry. What does dry stand for, Kevin?
Don't repeat yourself.
Don't repeat yourself. Exactly. Declarative, more readable code, map, filter, reduce, the most kind of readable way to write code and work with your data, right? Codesmith and a pro interview prep, right? So whether you're preparing for the Codesmith technical interview or a technical interview at another boot camp or program, or whether you're just going in for a technical interview for a job that you're applying for, all of the things that you learned tonight are extremely important. Practicing that technical communication, right? Walking through what is an execution context, walking through the different kind of like scopes of our global execution versus our local execution, our call stack, the thread of execution, all of these different pieces that we talk about, extremely important. And learning the right language to explain these pieces of information is going to set you up for success in any kind of technical interview, whether it's at Codesmith, another program, or the job that you're going to get after that program, or maybe the job you already have. Maybe you're trying to level up at your job. Carlos is already an engineer looking to make those kind of like next steps, right? Learning, kind of mastering the language is going to set you up for success. It's going to set you apart from a lot of other engineers. That's really what it's all about.